it is now time. We're about to go to our keynote speaker. And I'm going to allow a great friend of the university, an alumnus of the university, and someone who has supported Alabama A&M for many, many years and continues to do that. Baily, come on up and introduce our speaker, and also tell us a little bit about some things you're doing.
Very good. First of all, everybody call me Baily. Tomorrow you see me, I'll be Oliver Leslie. Okay?
Yeah.
Graduated from Alabama A&M in 1971 with electronic engineering technology degree. Spent 20 years in engineering at the Boeing Company. First 10 years was hands-on. The last 10 years was on the system side, which set in motion for the job that I'm doing today. I'm one of the company's small business liaison officers, and I'm the corporate program manager that forges technical relationship among selected HBCUs and MIs, minority institutions. Alabama A&M is on that list. I have a partnership with 13 HBCUs and about 12 minority institutions. As said before, we have had a long-lasting relationship with A&M. We're here today to enhance that relationship. Over the years, we've done research work with you, projects, etc. Most of all, we're interested in the students. So with that said, about me, I'll be around. I would like to introduce the keynote speaker, which I've known for a few years. A man, great integrity, commitment. When he says he's going to do something, he'll do it. If I'm having a few problems at all, I know who to call. Mr. Rick Baily is the Vice President of Engineering and Mission Assurance of the Boeing Defense, Space, and Security side of the Boeing Company. Rick leads over 30,000 engineers across Boeing. And without any further words, I bring to you Rick Baily, Vice President of Engineering of the Boeing Company. Rick.
Thank you, sir. Good evening. Dr. Glenn, thanks for the invitation which you extended when we were at Baily together. Bo, my colleague, thank you for that kind introduction, and more importantly, thanks for what you're doing for the students at the schools that you work with and for small businesses. And Jim Schaefer, my other colleague who's on the Dean's Advisory Board, thank you for introducing me to the school and what's going on, and for joining us tonight. And most of all, thank all of you for taking the time to be here. I'm honored that you would spend an evening of your time, especially kind of around spring break time and all that, with me and this evening. So thank you again. So I'm an aerospace guy, 30 plus years, and so if I have a kind of a theme for you tonight, it's going to be about dispelling myths a bit, and maybe the first one is to dispel the myth that aerospace is sort of the old school industry that's going away and doesn't have much going for it. Maybe you hear some things about sequestration and some other things around budgets in the future. But I'm here to tell you, despite those, which are just a small little blip in the track, in my view, aerospace does have a great future. Doesn't mean we don't have some challenges, but it's a great profession with a bright future, and I'll talk to you a little bit about that. Drew, if you can go to the next chart. So what I thought I'd touch on briefly is three areas. One, technology trends and some things I see going on there. One that is really an important challenge, we break the myths, which is affordable development programs for the aerospace industry. And then finally, the foundation that all of our work is done by, which is our workforce. And engineering workforce for the Boeing Company is kind of the lifeblood of our development and our future, so it's very important to us. And then we'll have a few moments, hopefully we can take, and I'll take on any questions or subjects that you want. So let's dive in. So arguably for the aerospace industry, the aeronautics and activity, it's been a pretty compelling century and a decade since the Wright brothers had their first flight in terms of what's been accomplished and the things that have happened in the aerospace industry. And I only see those accelerating in terms of the importance and the developments coming from technology. But there is kind of an interesting flip that's happened, which is in some areas, particularly networking, communications, and electronics, the commercial area has kind of been the driving force lately in terms of the things you hear about in technology development. And that's kind of a flip from what it was before, when things were, commercial areas, computers, other things were derived from defense and space developed technologies and then applied commercially. Now we're seeing the other trend happening, which is commercially, we're seeing developments that are now being brought back in and applied in aerospace and defense industry. But if you go to the next chart, to dispel one of the rumors, there's not a lot of cool technology going on in aerospace anymore. No, we're privileged to work on some pretty amazing things at the Boeing company for our abilities to protect and connect people around the world in the future. And here are just a few examples. Starting in the upper left is a autonomous combat vehicle that'll be able to do surveillance and yes, carry effects to our adversaries should they not want to work with us. A hypersonic vehicle that'll fly in the Mach 12 range. We're doing some testing on that now. In the upper right, Phantom Eye is a large autonomous vehicle that's powered by liquid hydrogen. So that actually has some forward combustion engines that bring in supercharged hydrogen, compress it, and then operate that way, and it'll go up to 60,000 feet with targets fly times of a week up to a month in the larger vehicles. Working on, in the lower right corner, some interesting technology to further improve the fuel efficiency. The X-48B is called our blended wing body, and that gets another 30% fuel efficiency over things like even our 787. The X-37B is the first vehicle to go up into space and land autonomously coming down. So this is that little Air Force spy craft, experimental craft they talk about. That was a classified program up until people could watch it in space, and then they talk about the vehicle, but you just can't talk about what's in the back end there. But that was an application of some new technologies and a lot of work on autonomy. And then finally, just to hit a bit on our commercial airplane activities, we have a series of aircraft that we call our eco-demonstrators, and we're putting some new technologies in there that help with fuel efficiency, reduce noise, and work on making the commercial aerospace side a more eco-friendly activity in the future. So that's kind of a segue into the next chart and some of the key things that we're working on there. In addition to things on the airplane, so reducing the drag on the airplane, reducing noise, increasing fuel efficiency so we can go faster and farther there. The 787, for example, is more than 20% efficient than equivalent planes in its size, and it can fly over 8,000 nautical miles. So it creates the opportunity to do point-to-point, basically halfway around the world. But in addition to just those basics on the airplane there, we're also working on technologies for the air traffic management system and in efficiency of routing. Now look, it'd be nice to say that's because if we're more efficient in how we do that and we don't do those big steps you do to get down to land, we can use less fuel, makes it more efficient. But there's another good benefit for the Boeing company, which is if we have a better air traffic management system and route things more efficiently, we can do more flights, and if you have more flights, that's more airplanes, so it's good for us economically. But there's a social benefit to it as well. And then finally, we're working with producers of other fuels, so biofuels we've run those in not only our commercial airplanes, but our military airplanes. So I don't know if you remember, maybe 2 years ago, President Obama was talking about the Green Hornet, which is the F-18 that they ran on biofuel. So energy and improving both the social dimension of the things we worked on as well as our products' competitiveness are real keys to us in the technology area. Next chart. Other things we're working on, electronics, open system architectures. That's probably an area we're borrowing back from the commercial segment. Flight deck design with ergonomics there, and I mentioned aerodynamics, and working with the engine companies who are making some real significant breakthroughs in fuel efficiency there. All key technology areas that we're working on. We look at universities as key partners, so the discussions we had earlier with Dr. Glenn about things that we could look at, because we rely on universities to help us not only with the people pipeline, but the innovation pipeline and new elements that we can bring into our design. So basic research, taking that hands-on technology development that brings your skills to bear as engineers, helping with continuing education, and then that STEM activity that builds the pipeline for the future. And I'll come back to that in a few moments. But the basics are, we're working on very exciting products. We have great technology. The pace of technology is increasing, and there's a lot more collaboration between aerospace and defense industry and commercial areas, as well as universities. And bringing those together is another mechanism that can improve that. So let's go on to our next challenge. One of the challenges that we do have is facing into some of the budget issues of our customers, looking at global competitiveness in our commercial market. The basic facts are we've got to be continuing to do more for less. And that may seem like, well, why did it take so long for the aerospace and defense industry to figure this out? Everybody else has been on that kick for a long time. But it's just part of the reality of what we've been doing. The other thing is we're taking on a lot more risk and paying for a lot of this ourselves as an industry now, which has been more of a commercial idea, but not done so much in the large aerospace programs. So we need more affordable systems. We're doing a lot of international work, and we have to implement a series of steps to ensure that we can do that. Go to the next chart. Now look, like to say that there's some new physics about how to go about this, but we really know the things that we need to do to make that happen. We need to really focus on value trades and assuring that we get the important things to have our customers value. Got to do a lot more on product line reuse, and we do that effectively in some areas, not so much in others. Really focus on how we execute development programs, early experimentation, early integration to drive out risk, and then lean and efficient methods of getting through and getting through test programs. Unfortunately, we haven't had such a good track record over the last few years. The left chart there is a DARPA developed evaluation, which shows in the kind of purple that aerospace, large complex aerospace systems have continually gone up in cost for a given complexity. And autos and integrated circuits in the green and red there, they have actually also increased in complexity, so we can't use that argument to hide behind. But they've been able to manage and keep more consistent, or in the case of auto companies, reducing costs over time for the complexity. Now granted, they have a lot of volume, which helps in their development activities, but they've done a great job on reuse in systems underneath that car that looks different to you from the outside. The suspensions, the engine, the electronics, most of the things are reused across product lines, and we're going to need to do more of that. The other thing, because of the risks and the challenges that we do take on and the types of products we work on as aerospace, is we tend to have too much in the test fail fix cycles that increase the cost and the timeline for delivery. And a large fighter jet program, which will remain unnamed, is in the paper a lot with those kind of challenges where things don't work out quite like you expect, and you have to recycle, redesign, and redo. So that's a lot of cost and schedule to get that done. And in fact, even in our own data, we're finding things later in test out near the end of our gated process compared to where we think we could and eliminate at a lower risk. So we do have some things to work on. But let me give you an example where we're trying to take those to heart and do what we know to do from the beginning, and it's a local one, which is the Space Launch System. So Boeing is part of the NASA team for developing the new large launcher capability for the United States, and it's called the Space Launch System, SLS. And we're actually trying to work that because of their budget constraints and to make sure that we get those. So what are we doing? We're working on reusing a lot of the key elements in there, from the booster elements to the avionics to the upper stage, and so that reduces risk and allows us to product line those with other things that we're doing. We're also trying to reuse processes where they make sense, even if the vehicle's different. The large booster element on there is almost 4 times the size of the largest rocket in the US inventory, called the Delta IV, 4 times larger. But they're using the same technology for what's called friction stir welding to develop the materials, and so they're able to reduce risk by applying the same processes there to do that. So the myth we've got to break here is that we can't we can't stem this continuing rising cost in development programs, and we know how to do it. We're going to do it through combinations of effective program management and focus on requirements, reuse strategies across product lines, and then executing programs with a mindset of driving out risk to the left. So that's our second area. The third area is maybe a little closer to home for the students here that I wanted to touch on, and that's our workforce. So we go to the next chart. So this is aerospace industry average, and is public data which says that by the next 3 years, we'll actually be up to over 30% of our workforce eligible to retire. For the Boeing company, in the next 5 years, 50% of our workforce will be eligible to retire. For us, that means 55 years old and 30 years of service. Most of them don't, by the way. They tend to work 5 to 6 years longer than that. But still, even if you take that into account, that means we're looking into replacing half of our technical workforce in the next 10 years. So imagine what that means for the students coming in. I mean, to me, it's the best time in my 30 plus years in this industry to be earning a degree in engineering and coming into work. Why is that? One, you still got some senior people left that you can learn quickly from, and you can understand and accelerate your learning curve and development, get some of their domain experience, which really does count in how things work. But then they're going to be gone, so you're going to have great growth opportunities in terms of the types of things you're working on, leadership and management, if that's your key. And so it's really a compelling thing in my view in terms of the opportunities for the students coming in with technical degrees. Next. So what are we looking for? One of the things I emphasize always is a really good, solid understanding of the fundamentals of engineering. So I'm a stress engineer, and when a new engineer comes in and says, I'll start working on a finite element model right away, and they haven't sat down and done the free body diagram to understand what's really happening here, they're not even going to know whether the answer coming out of the tool is right. So make sure you got the fundamentals right, and then apply the tools to accelerate and deepen the work you do on versus the other way around. Ethics and integrity and safety are really important to us, and they're key things that engineers influence every day, not only in their personal behavior, but also in the products that they design and how safe they are for the users and the people that build them in the factory. So that's another high one on my list of these characteristics. And then finally, the other one I'll highlight is a curiosity and a desire for lifelong learning. You won't know what you need to know when you get out of school for working there. You won't know what you need to know for other opportunities even after you work some period of time. You always are learning and growing, and we want people that are excited about learning and growing to be their best all the time. So what do we do to help that, for examples, in our company? And I guess this is closest to the paid advertisement part of all of you considering Boeing in the future. We have Learning Together program where you can go back and get an advanced academic degree. I came to Boeing, I worked for a couple years, and then I went back and got my master's degree in engineering to deepen my skills there. We have an engineering leadership program to allow engineers to work on projects outside their normal area and grow that way. We have a technical fellowship program. Jim is a technical fellow to allow us to reward and recognize those that want to stay focused in the technical area. We're involved in a lot of affiliations. Marilyn, I was just thrilled to hear your focus on STEM and finding others and bringing them in, because we're very focused. Obviously, we have to fill the talent pipeline to succeed in the future. And then we work a lot with mentoring process. We polled our engineers, we talked to them, maybe seems kind of intuitive, but they told us overwhelmingly, I learn best by having challenging assignments with someone there to guide me in the learning while I'm doing it. And so we have a lot of mentoring programs and work that diligently to help people develop as they go. So we're about having an environment where people can be at their best and grow, and with this bringing in and replenishing half of our workforce over the 10 years, the next 10 years, there's never been a more important time for us to be focused on that. And we want the best coming in to help us in the future and to help themselves grow. So the real question that we talked about today is, what role could we have together? What things could we do to fill in Boeing's historical map as we come up to our 100 years and get the new pictures and iconic products and services for the rest of the world? And we look forward to the collaboration, Dr. Glenn, and looking forward for opportunities to work together, as well as have some of your students come work for the Boeing company. Thank you.
We have some time for some questions, so if you have any, because I have some myself, so
Okay.
Right here.
I have a small challenge to you about something that you put down.
Okay.
You're showing that you weren't keeping up with a couple of other industry areas. The electronics as the closest thing I can think of. It doesn't look like these things are following Moore's law properly.
Well, you saw what you saw there on that was that they have dramatically increased the complexity. So on an integrated circuit, right, there's more elements on a particular integrated circuit. But similar to auto, they reuse a lot of elements of the design in modules and put those together in now massively integrated circuits. And that's really how they're kind of getting on that curve where they're able to get that complexity with small development times. And that's really a very particular thing. That was integrated circuits. That's not avionics systems or other elements. But it's just an example of some of the strategies that we benchmarked to really go after to develop that. And in that case, they use modular reuse of electronic component designs within there to achieve that. Any of my colleagues want to add, or they're your professors, they can jump in there too. Okay. Hi.
So you mentioned that in your development, your failures are more than what you want them to be.
Yeah, in development programs. We've got to change,
Yeah.
yes.
So my question is, how are you using modeling and simulation to help you reduce those failures?
Yeah, so we are, it's one of the areas where the tool development is helped us a lot. Some of the key things are we're using everything from that value engineering element that I talked about, focusing on requirements. So we do a lot of, for our defense customers, a lot of mission analysis where we can understand how the product allows them to do their mission more effectively and what the trade-offs are. And you don't want to invest in things that don't make a big difference in mission outcome, and you want to invest in things that have a high response there. So we're using it in that. The other area we're doing a lot more of, because we've traditionally done the stress analysis and thermal with the right tool set, but we're doing a lot more integrated, multidisciplinary analysis and optimization. So MDAO, as the acronym is one of the areas where we're seeing a lot more efficiencies and effectiveness and helping us start to drive out some of those issues later in there. And then the other one is just to recognize, the other strategy we have, just to recognize where you don't have a knowledge point or you can't do the modeling in sim. Then I want an early experiment to understand where we're at from a risk standpoint so we can look at the options there. So those are some of the key things we're doing. And like I said, the reason we know the answers to most of these questions is that some programs have really been successful in doing it. There's a bunch of them that aren't on that curve. That's a general industry one from DARPA. But we have some good examples where we've done it right, so we're, of course, emulating those examples. But there's going to be a lot more modeling in sim. Those are much more capable these days. There's a lot more physics-based modeling that we're able to apply. And just to give you an example, on our aero stuff, the performance on our commercial airplanes, there's very little risk on that now by the time we're into the flight program. See if I can figure out, I remember one example, back in the early days of the 747, they tested, if I remember the number right, over 80 wing configurations, wind tunnel testing and others to get it. We tested 3 on the 787 because the rest of them we did with modeling and simulation to screen out and understand the best candidates, and we only tested and anchored 3. So that's an example of the kind of efficiency you can get in areas where you have that capability to model with that depth and accuracy.
For the students here,
Yeah.
You're saying that give about 10 years, or in the 2020s, a little bit after, there's going to be a great need, and not just for Boeing, but for many other companies as well. So tell us what the profile, the characteristics of a successful young engineer in a company like yours is going to look like given that situation.
Yeah. So I didn't mean to say it's 10 years to get there. It's ramping up, but boy, what opportunities they'll have. Well, look, I talked about a few of them. One, things that stand out are really sound grasp of the fundamentals and able to translate those into outcomes in the projects they work on. People that are comfortable working in team environments and with virtual partners as well. So good collaboration skills, communication, willingness and ability to do that. And then, look, a lot of this is tough work. So persistence and ability to stick with things and work hard are other characteristics that tend to separate folks out on teams that I really notice. One of the things that I kind of fell upon that I didn't realize was a sort of a career strategy, but really worked is being avid volunteer. So whether that's out in the community and working with other groups where you learn leadership, you learn project management, working on something at your church, working on a STEM environment, whatever that is, when people come in and say, I didn't have a chance at business to lead a team yet, and that's what I want to do eventually, well, go lead a team somewhere else and then talk about that experience that you have. Volunteering at work. Some of the best things I got to work on were because they said, we need somebody to go this special activity, it's going to be some extra stuff. And I said, I'll try it. And I met some people, you get another chance to work on a project, you get some networking, you get different experiences than you had. So volunteering is another very powerful characteristic that allows people to maybe grow to their potential a little faster and succeed in business.
More questions?
Yes.
On your vehicle you show in there, the hypersonic vehicle, Mach
Mhm.
12, What, in your opinion, what is the future of the hypersonic flight?
Yeah, it's been a little tough to tell. Hypersonics, maybe a bit like chemical lasers, was always those things that's going to be here in the next 20 years, and it's always 20 years away. That's a really tough physics problem on combustion, okay? So a lot of the challenges, which have been even hard to model, are the combustion regimes you get into, and the fact that you can go through several from when the vehicle starts, gets a little rocket boost going, and then you have to start the ramjet engine and go through different things. So look, the ones we're working on, candidly, are so that we can have people here and get some effect over on the other side of the world in an hour without an airplane flying over and dropping something on them. Do I think we'll get hypersonic flight for commercially transporting people? Not too soon. There's so many challenges with temperatures and other things to do. That'd be nice to think I can fly around the world in an hour and a half, but you can't get off the vehicle for 5 more hours because it's got to cool down. So I think it'll stay in the, I think it'll kind of end up staying in the defense realm for a while. But we're making some progress on real tangible capabilities that might be able to be delivered. And I'm going to say more in the 10-year range than 20 years, but it's also not next year in terms of producible system. Yeah, I think credibly, if you just really look at the uses, that's the most realistic application for the time being. There's just too many other logistics challenges with hypersonic flight, I think, to make it credible in the near term for commercial. Yeah. Mm-hmm.
How important is that in getting a job, keeping a job, having, good writing?
Yeah, absolutely. Well, I think it's very important. It's particularly important if you aspire to be a leader or have large groups, because you're going to be communicating in all dimensions often, and writing's certainly one of them. I have to tell you, I thought that was important. I took a couple extra writing classes when I was in college, and they paid off not long after I started, because I started working on proposals. Where guess what? We write proposals to describe our technical approach and our technical detail of what we do. And those are how we win business. So is writing important for a business? Absolutely. And I started working on proposals. They noticed, hey, he does pretty well. Now, that got me more proposal work, which was kind of tough, but it also got me some other opportunities. And the difference in terms of being able to articulate things, I can tell you at more to the executive level, it's a huge differentiator if you're a good writer versus not, and it's really easy to figure out. So thank you for what you're doing, and I hope a lot of the students here take that to heart and go into your course, because it'll help them in their career tremendously.
You mentioned have the fundamentals down,
Yep.
and then apply them to tools, and you mentioned tool development. Can you give me some examples of what tools you're talking about?
Okay, so analytical tools, design tools, simple ones we use all the time, CAD, electronics design, CFD, all of those. Interestingly enough, one I probably spend more time on than those is the basic product data management systems that we archive our massive product databases in, and so we have even specialists in those areas. The one I think has the most promise and for the future is these elements where we're able to combine and do multidisciplinary analysis and optimization. And I'll say maybe the optimizer tool, parts of those aren't so critical, but the integration of these other physical tool sets, and combining those together to do the analysis, do a lot more cases and find the best optimized point. Those are an area of concentration for us. So not so much individual tools, but how do we combine them to get a more integrated answer is kind of the trend I'm seeing more of.
You're talking about modeling.
Yeah.
What percentage of modeling do you use to keep the failure rate down that you're having, that you expressed in one of your slides?
Well, there's probably not much of anything that we aren't doing a combination of modeling and simulation and testing on. Right.
80%, 70%?
Yeah, it'd probably be in the 80+% range. I mean, all of our platform products for sure have those. Maybe not quite so much in our electronic systems. Tend to, we do some software simulation of hardware systems that we then run software on to reduce costs and drive out earlier identification of software issues. But those we tend to graduate pretty soon to electronics integration lab, a system, a SIL type of environment there. That's probably an area that is still growing, and I know there's a number of companies that are working on that. But you see it most everywhere. I think the magic is integrating those and combining them and working on optimization that way for the future.
Appreciate that.
Well, let's thank our speakers. So first of all, I want to, Marilyn, come on up here. To show appreciation with this beautiful certificate of appreciation for your contribution to the speaker series.
She was very interesting.
There's a gift as well.
Wow.
We have, as usual,
Oh, it's beautiful.
yes, something to remember us by, and I'll carefully, well, I won't take it out. I'll just hold it up like this.
Good idea.
But it says, presented to Richard D. Baily, Dean Speaker Series, March 28, 2013.
Thank you.
All right.
Thank you
Thank
very
you very
much.
much. And here's also a little token
Wonderful.
of our appreciation.
Thank you.
Thank you for being here. I was telling Rick that one of the criteria for getting him out here to speak was we needed to find somebody that was a little taller than I am. You fit that bill. I want to thank our speakers, but also thank all of you for coming out. I wanted to thank members of our advisory board, Dr. Watson, who was here, Dick Schaefer, thank you for being here. Members of our, formerly of our faculty, but Professor Massey, thank you for coming out, still advising us. All the faculty who are here, thank you for being here. And also thank you for inviting the students to come out and listen. And I also want to thank all of the students for being here as well. Did you get something out of it tonight?